All right, so I'm looking at a slightly harder optimization problem, still pretty classic sort of situation where you've got a rectangle, and the rectangle here is 24 by 45, and we're going to make this into a box by cutting out squares from each of the four corners and then folding it up. And you can see how this would make a nice little box. It doesn't have a top of the box, but you can still cut the corners up and then fold it up, and you've got a nice little box shape there. And what I want to know is the largest volume and what the dimensions are and what the largest volume is. And these are measured in centimeters here. So my volume formula here is just length times width times height. So let's say that the length is 45. Well, when I fold up my box, it's not going to be 45 anymore because I cut the corners. And I'm using the letter X to stand for the size of the corners. And so it's actually 45 minus 2X because I had 45, but then I cut out X here and I cut out X there. So this remaining distance in between is 45 minus 2X. Similarly, if I cut out the other two corners on the width, I have 24 minus 2x, and then if I fold it up, the height of my box is x. You can choose if you want to use your function as is, or if you want to simplify it a little bit. I don't really like it when I have three factors, so I'm just going to distribute the x in like this, and then I'll use my product rule to look at v prime. So my v prime is going to be negative 2 times 24x minus 2x squared plus 45 minus 2x times 24 minus 4x. I need to figure out when this equals 0. So I guess there's no way around it. We just need to multiply everything out. So negative 48x plus 4x squared plus, and then I'm going to distribute. So 45 times 24. So we have 1080, and then 45 times 4 is 180x, and then we have 2 times 24 is 48x, and then 2 times 4 makes positive 8x squared. Okay, I guess this is what we're doing. So we're going to keep going with this. So I have 12x squared, and then negative 180 and 48 and another 48 minus 276x plus 1080. I think 276 is divisible by 12. Yeah. So I divide by 12 and I get x squared minus 23x, and I hope 1080 is divisible by 12. Yep, it's 90. And then can I factor that? Let's see, what is 90? 9 times 10. That's not going to work. I could do 18 times 5. That'll work. Okay, great. So we have x equals, 0 equals x minus 18 times x minus 5, telling me my two potential solutions are x equals 18 and x is equal to 5. One of those doesn't work. Think about which one doesn't work. The x equals 18 does not work because if x is equal to 18, I wouldn't be able to cut out two squares from the 24 length side. So x equals 5 is the one that works. And then I go back to my volume formula and I plug in 5. So my length is 45 minus 10, so 35. My width is 24 minus 10, so 14. And my height is 5. So 35 times 14 times 5 is a volume of 2450. So that's the total volume. Now I really should make sure that that is a maximum by taking the second derivative or doing the first derivative test or something like that. What I can do is look at, this is my derivative still. This is also equal to my derivative here. And I can bring the 12 down instead of dividing by it. It doesn't change the positivity or negativity. And then if I look at, I'll do the first derivative test because I don't feel like taking the second derivative. If I plug in a number smaller than 5, if I plug in 4, then I have here a negative times another negative. So that means the function has a positive derivative before 5. And if I plug in a number like 6, I have a negative because 6 minus 18 is negative, and a positive because 6 minus 5 is positive. And so it's negative after. So by the first derivative test, I know that that value of x equals 5, that critical point, is a maximum. And there you go. So that's a little bit harder of an example of optimization, but it's the same basic idea. You set up your equations, draw your situation out, take your derivative and set it equal to 0. A little bit of calculator help with the factoring and solving. So comment or ask questions if there's anything that was confusing. Thank you.